IPv6 address, global unicast address. In this video, I'm going to talk about global unicast address or GUA. As you remember in the previous videos, we talked about IPv6 addresses and especially about unicast IPv6 addresses. You know that we have many types of unicast IPv6 addresses, okay? For example, you learn about unspecified IPv6 address, one type of unicast IPv6 address. Then loopback unicast IPv6 address. After that, unique local IPv6 address, same as the or counterpart of the private IPv4 address. And then, for example, link local IP address, IPv6 address. And now I want to talk about global unicast address. Global unicast address or GUI, globally unicast address, or maybe in some references you see globally unique address, globally unique or globally unicast address. Okay, both of them are same. In this video I'm going to talk about this global unicast address, the most important address types in the IPv6. Look at here, this is IPv4 addressing, and you know that in IPv4 addressing we have three type of IP address and three type of communication. Unicast means one-to-one, multicast means to one-to-many, and broadcast means one-to-all. And you know that in unicast IPv4 addressing we have unspecified unicast IPv4 address, loopback unicast IPv4 address, and also private unicast IPv4 address. You know that we have in IPv4 another important type of IPv4 address that we call it public IPv4 address. Public means this type of IP addresses can be routed into the, for example, internet. You know that every IPv4 address that are not unspecified, loopback, private, multicast, and broadcast, all of the others are public IPv4 address. So easy. And also, counterpart of this public IPv4 address is globally unicast address in IPv6. Look at here, globally unicast address, or maybe you hear globally unique address, because these IP addresses should be unique in all over the world in global, okay, globally unicast address. And this type of IP addresses are same as or counterpart of the public IPv4 addresses, and it can be used for routing in internet or maybe inside of your company. Okay, in this video I'm going to talk about this GUA, but first I want to show you the basic structure of the GUA address. After that we can delve into the detail of the globally unicast address. You know that, for example, in IPv4, if I want to compare IPv4 with IPv6, you learn in IPv4 in old days, for example in your CCNA studies, okay, you learn that every IPv4 has two parts, network part and also host part. For example, when I give you this IP address 192.168.1.1/24, this means that the third octet 192.168.1, the 24 bits are the, for example, network or subnet, okay, network part, and the last octet 1 is the host part. You learned about it in the CCNA, okay. You know that every computer, every host in the same network should has the same network ID. This is the network ID, okay. If you want to find network ID, you should use, or network address, you should use for all of the host bits 0, okay, 192.168.1.0. This is the network address, okay. And also if you want For example, to find the broadcast address, you should use 1 in all of the host bits. 192.168.1255. This is the broadcast or locally broadcast address. You know that in IPv6 we don't have this special IP address, broadcast address. In IPv6 we don't use broadcast. Okay, this is for IPv4. In a network, inside of a network, all of the hosts should has the same network address, and all of the hosts in the same network should has the different host ID or host address. This is for IPv4. And similarly, in IPv6, when we have an IPv6, we have two parts. The first part is prefix or subnet prefix, and the second part is interface or interface ID. Okay, subnet prefix means network. This is the counterpart of network in the IPv4, and interface is the counterpart of the, for example, host ID in the IPv4. Let me to show you. Look at here. I want to use an example, IPv6. This is an IPv6 2001 DB8. Okay, 1 1, then 1 2 1 2 3 1 1 double, and then /64. That's it. Look at here. As you can see, again in IPv6 we are using /1 number. This is the numbers of the bits that we should use, we should understand for subnet prefixes. Okay, for example, when we are using /64, because every hexstat has 16 bits, this means that 4 hexstat, 4 multiplied 16 equals 64. 4 hexstat are our subnet prefix, okay, and other hexstats are our interface ID or interface or host ID. For example, interface means host, subnet prefix means network. For example, in this IP address 2001 DB8 11, okay, is our subnet prefix, same as the network ID, and also 12.123.1.1 is our interface ID. This means that all of the PCs in the same network should has these 4 hexstat as at the start of their IP address, because all of them in the same network, they should have same subnet prefix, but all of them should have the different, okay, interface ID, same as IPv4. Let me to show you and understanding more about the IPv6 globally unicast address. Assume that here we have a network, okay, we have a network. In our network we have 3 PC1, PC2, and then PC3. Our PCs, okay, connected to one switch. This is PC1, then PC2, then PC3, and this is our switch. Okay, all of them connected to the switch. For example, with port fast Ethernet 01, and then fast Ethernet 02, and then fast Ethernet 03. And after that, switch connected with the fast Ethernet 04 or GE01, okay, to the router with the GE or gigabit Ethernet 00. This is the router's interface. So easy. Okay, I want to address this network for PC1, PC2, and PC3, and also gigabit Ethernet 00 of router. I should use the same range. For example, if I want to use this range for this networks 2001 DB8 11:/64. What does this mean? You know that if I want to find the, for example, subnet prefix, same as the IPv4, we can use all of the interface ID bits